triangle trig. And while I'm thinking about it, the first thing I want you to do, go to your calculator right now and go to your mode and make sure that your calculator is in degrees.
What chapter is this?
Okay. Now I have to tell you, when I clear these calculators, and I do that about once a week, it puts your calculator back in the radians. And because we're dealing with triangles, and we're dealing with angles, we're dealing with degrees right now. As we get into it more, we'll be dealing with radians. And I think you're going to find once you get to calculus, everything is in radians. All right. Okay, but right now we're in degrees, and we're going to talk about right triangles. Some stuff you know. Some should be a review from geometry. And there are 6 trigonometric, 6 trig functions. They are sine, cosine, tangent, cosecant, secant, and cotangent. And these are the 6 trig functions. Now we should be familiar with sine, cosine, and tangent. The abbreviations for sine, S-I-N, and the sign of an angle, and that's a symbol, that's a Greek symbol, theta. The other trig we use Greek symbols alpha, beta, and theta. Okay? Sine of theta in a right triangle. Okay? Opposite, so the opposite side over the hypotenuse. It's a definition of the sine of an angle. It's the measure of the opposite side over the hypotenuse. Cosine, which is abbreviated COS, of an angle, is equal to the adjacent side over the hypotenuse. Adjacent, meaning, what's adjacent mean? Next to, right. Okay. Tangent, which is abbreviated TAN, of an angle, is equal to the opposite side over the adjacent side. It's that ratio of the opposite side, measure the opposite side of a right triangle to the adjacent side. And these 3 are in your calculator: sine, cosine, and tangent. There is cosecant, secant, and cotangent are not in your calculators. All right, so we have to do a little manipulation before we get to those. Cosecant, which is abbreviated CSC, is actually a reciprocal function. And cosecant of theta is the ratio of the hypotenuse to the side opposite. And it is a reciprocal function of sine. It's actually 1 over sine theta. Cosecant is 1 over sine. It's a reciprocal function, not inverse. It's a reciprocal. Secant, SEC, is hypotenuse over adjacent, which is a reciprocal of cosine. Secant of an angle, secant is 1 over cosine. Cosine is 1 over secant. They're reciprocal functions. sine, reciprocal, sine is equal to 1 over cosecant. Cosecant is equal to 1 over sine. They are cofunctions. Sine and cosecant are cofunctions of each other. Okay, one's one's not. Cosine, secant. And then cotangent, which is COT, is adjacent over opposite. And of course, that's 1 over tangent. And those are the 6 trigonometric functions. So let's take a triangle. Let's take a right triangle with measurements 8, 15, and 17. And let's label this ABC. Right? The triangles are labeled, the angles are labeled with capital letters, and the sides are labeled with lowercase letters. And side A would be the side opposite angle A. Side C would be the side opposite angle C. And side B would be opposite angle B. All right? And I think if I remember my geometry correctly, I think triangles are labeled clockwise. Is that right? Does anybody know? Can it go either way, clockwise, counterclockwise?
I think it's clockwise.
Is it clockwise? I kind of think it is, but I don't know. All right. So you might get a problem like this that says find the value of cosine of B. Give an exact answer, exact value, and a value rounded to the nearest 10 thousandths. Scotty, 10 thousandths. How many decimal places?
That would be
4. The cosine of angle B would be adjacent over hypotenuse. That's the exact answer. And then you go to your calculator. 15 divided by 17. 0.8824. So it says give the exact answer, which is the exact value, which is 15 over 7, and then a value rounded to the nearest 10 thousandth, 0.8824. Easy enough, right? And so what is cosecant of angle B? Right, and this is what you want to memorize, this whole column on the left. That's what you want to memorize. And we know that cosecant it's a reciprocal of sine. Cosecant is a reciprocal of sine. Sine of angle B is 8 over 17. So cosecant would be 17 over 8. And then whatever that decimal is, 2 point something. Rounded to the nearest 10,000. Okay, do you have a question, Hunter? I don't think there's any. Cosecant is hypotenuse over opposite. If you're thinking of cosecant as being a reciprocal of...
I was trying to figure out the letters.
Oh, the letters?
I didn't know if it was an S or no. Yeah.
Yeah. My writing's not always the greatest.
What is it?
You mean right here?
No,
Yeah, CSC. All right.
Wait, CSC or CSE?
CSC. CSC. Yeah. All right. Okay, and then whatever the decimal is, I gotta believe it's 2.0 something. 2.125. Is there another? because we want to round it to the nearest 10 thousandths. All right. Just for the heck of it, sine of angle B, all right, which is a reciprocal of cosecant. Well, we know sine is equal to the opposite over hypotenuse. It's important, and I'm hoping that you guys remember this. If not, it's okay. But sine and cosine of an angle have to be less than 1 or greater than -1. All right? You'll notice that 8 over 17, 15 over 17. Okay. Did you guys, in geometry, did you graph a sine curve? You didn't graph a sine curve or a cosine curve? Right. It's just kind of a wave. It's kind of a wave. And it goes up to 1 and down to -1 and up to 1 and down to -1. But it never goes up beyond 1, a regular cosine curve. Okay? All right. This is how you're going to be doing problems 8 through 31 on your homework. So it kind of gets you used to these ratios, these sine ratios, cosine, tangent, cosecant, and so on. All right. Easy enough, I think. All right. Solve the triangle. Solve the triangle. So let me give you a right triangle. And let's say this side is 6.4. Let's call this JKL, triangle JKL. 6.4, and I'm going to say angle K is 41 degrees. Solve the triangle. All right? So, when they say solve the triangle, I want all angles, all sides. Not bad. L, so angle L is 90 degrees. No problem there. It's given. Angle K, 41 degrees. No problem. It's given. And we can easily figure out angle J, which is 49 degrees. Okay? Don't forget to put the degree sign there. Put the degree sign. Without a degree sign, then that measure is in radians. Okay? So we need that little circle. All right, and what else we have? Side J given 6.4. All right. Could you guys close the door for me, please? Thank you. All right. So let's find side K. I guess we could find side L if we wanted to. Well, let's find side K. Side K. I've got an opposite side, and I've got an adjacent side. What function do we want to use? Tangent. So the tangent of angle K, which is 41 degrees, is equal to opposite side K over adjacent 6.4. You're going to find that the math involved in trig should be fairly easy. Okay, but it's the memorization that we kind of get bogged down with. And all we have to do is multiply both sides by 6.4. 6.4 times tangent of 41. So put that in your calculator for me, would you? And round your answer to the nearest tenth. And you don't need parentheses, just 6.4 tangent 41. What is the mark? 5.7. So side K then is 5.7. Rounded to nearest 10.
Oh,
5.6. Thank you. All right. Everybody with me? All right. How do we find side L? Pythagorean theorem is one way, yes. What's another way? We could do what? Cosine or sine. Let's use sine. Let's go for my original, because I know that the sine of 41 degrees is equal to the opposite, which we just found. And you know what? I think I'm going to do the original one. No, we can go for the 5.6. Opposite over hypotenuse, and that's what we're looking for, side L. And we do the math. Multiply both sides by L. I will get L times sine of 41 degrees is equal to 5.6. And I divide both sides by sine of 41 degrees. All right, if you put that in your calculator for me. What is it? 8.5. And so side L then would equal 8.5. To me, less steps here than doing Pythagorean theorem by using your trig ratios, don't you think? Maybe not. I mean, whatever you feel comfortable with. Okay, solve the triangle. Is there any questions on that? Yeah, Michelle.
So once you only need one more side left, it doesn't matter if you do like cosines or like you could do either of the options.
Yes. Yeah, you get the same answer. Do you know that the sine of 41 degrees is the same as the cosine of its complement? Was that a geometric ratio or not? Look, this is 49 degrees, isn't it? The sine of 41, opposite over hypotenuse, is the same as cosine of the complement. There's the complement, 49 degrees, adjacent over hypotenuse. So the sine of 41 degrees is the same as the cosine of 49 degrees. Put it in your calculator and you'll see. Hit sine of 41 equals, and then hit cosine of 49. You get the same decimal. All right, let's take another triangle here. Solve the triangle. All right, angle C is 90 degrees. I'm looking for angle A, angle B. And we're going to have to round these, I think. And I'm looking for side C, side A, which is 3.8, and side B, which is 6.8. Solve the triangle. Well, I'm not given the hypotenuse. Which function am I going to use? Remember, your calculator only does sine, cosine, and tangent. So we're going to have to use tangent. So let's find angle A. The tangent of angle A is equal to opposite over adjacent. Correct? Now we go to our calculator. And you'll notice that underneath sine, cosine, and tangent, the second function of sine, cosine, and tangent is an inverse function, not a reciprocal, inverse. And that allows us to find the angle. So in your calculator, you want to hit second tangent, and then that ratio. Now, who's got an 86? Beth, you have an 86, right? You have an 86. Did it bring up a parenthesis? Like I did second tangent, did it bring up a parenthesis? And you have to put one in there. So second tangent will give you tangent -1. You have to open up a parenthesis, and then you put that ratio in there, 3.8 divided by 6.8. This is why you have to make sure your calculator is in degrees. And it gives us, let's round that to the nearest tenth, or 29.2 degrees. So that gives us the measure of angle A at approximately 29.2 degrees. That means that angle B is going to be 60.8 degrees. Whatever adds up to 90 degrees there, right? Now, if I want to find the measure of angle C, I could use trig functions, or I could use the Pythagorean theorem to find side C. I think I'm going to use, I think I'll use sine. The sine of angle A is equal to 3.8 over the hypotenuse. Multiply both sides by C. C times the sine of, we just found that at 29.2, equals 3.8, and make that division. 3.8 divided by sine of 29.2. Yes?
Okay, is that inverse tangent the same thing as cotangent?
It is not. It is not a reciprocal. It's an inverse. It gives us a way to find the measure of an angle. It is not a reciprocal.
So
Even though it says, and I understand, even though it says sine -1 power, it does not mean 1 over.
okay.
Okay?
Okay.
Yeah.
So the inverse you use to find angle.
Yes, inverse we use to find angles, yes. If you recall, inverse, you switch the x and y. Yeah. So it's not really a multiplicative inverse. It's not a reciprocal. All right. Is that clear? Have any questions for me on that? That's really all that's involved here in this first section. So the homework for tonight is going to be on page 833 and 834, 8 through 47. All.
Have you finished taking the test?
Pardon?
Have you finished taking
I have not. I still have about a half dozen people that need to take it still. So when everybody gets done taking it, then I'll grade them.